Developed for design and implementation of a single cycle 32-bit RISC processor on FPGA using Verilog HDL files. Okay, so this I have just added the abstract for the FPGA file in which we have used the arithmetic logic unit which performs the addition, multiplication, subtraction, and the division. And we have used the memory register file, data memory. Let me just explain you in form of block diagram. Yes, this one. This is the main block diagram used in our system. Basically, the thing is that, let me just, okay. So basically, this is a control system in which we have used the branch, jump, memory read, memory register, ALU, memory write, and all the things. And these are the read memory file. This is the ALU which will perform multiplication, addition, subtraction, and division. And this is the read address instructions in it and addition as well. So all the equations and ALU control system used in this section, and the write of memory added in this section. Okay, read of memory, this section, instruction mode, this is the instruction mode, this is a reading mode, and this is a PC included. Okay, so this is a block diagram overview. This is a design methodology which we have used AND or XOR gate for the add and subtraction, and we have also used memory access, switch, jump instructions, and arithmetic logic units, and all the control unit added in it. So synthesis of FPGA development are added through Vivardo, Xilinx Vivardo. So these are our architecture of process diagram, like how our single cycle 32-bit RISC processor will work. So these are the outputs, like this output results for single cycle 32-bit. In the output results, we can also check that, like for example, these are the all the register write, clock, reset, memory to register, ALU screenshot, ALU screen, and the memory write, memory read, ALU opcode, functional, and ALU results, R type, and switch mode and R type. Okay, all the output results are added in it. So these are the also test output results. These are the final output results for the memory test outputs. Okay, this is the RTL diagram for the single cycle RISC processor. Okay, after that we have added the complete table which is providing us the LUT used and flip-flops, BRAM blocks, max frequency, and power consumption. We have just developed this complete section in 62.5 megahertz frequency. Okay, so these are the conclusion and added references added. Let me just show you, these are the ALU block which provide us the complete code for Verilog code, and the next one is basically ALU add only. This perform ALU add and all the control section added in it. Okay, see all the code added in it accordingly. Okay, divided by 100k. Clock and reset also added, program counter also added in it, synchronous counter, rising edge, synchronous program counter. So output results are there. We just added all the output results accordingly. See the output results, and the next one is basically I have just added like for example, these are the RISC graphs. For example, yes, these are the FPGA board accordingly, and as well as the DigiSilent basic systems. Okay, so let me yes, this one. So these are the Vivardo files are available, like this is a Vivardo project files are available in it, and these are the table used for this RISC processor, but all the files are here. Okay, I have added all the RISC tables, including the Xilinx Vivorder software, everything included in this sheet. So this is the complete project. This is a single cycle complete Verilog code, and last one is single cycle test bench. This is the test bench, like we can just check it's all the results after 10 seconds of each cycle. Okay, so I think it is okay now. Thank you.